Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving greatest integer function, right? So here today we'll have an important problem. We have to find the value of this integral that is from 0 to pi by 4, and here we have the greatest integer of 1 plus 2 times cosine square x, right? So here the integrand is a greatest integer function, so we'll apply the definition of greatest integer function, and the method of integration by substitution will also be made use of, right? So let us first take this integral as I, and we'll take the substitution, that is t is equal to 1 plus 2 times cosine square x, right? So here we see that x varies from 0 to pi by 4, and we are assuming t is equal to 1 plus 2 times cosine square x, right? So now this equation can also be written as t minus 1 is equal to 2 times cos square x. So cos square x is t minus 1 over 2. So we can now write cos x is equal to square root of t minus 1 over 2, right? So now here the limits of integration varies from x is equal to 0 to pi by 4, right? So in order to calculate the value of t, what we will do, will substitute these values in this expression, right? So when x is equal to 0, then the value of t is 1 plus 2 times cos square 0, and cos 0 is 1, so we have 2 times 1 square, that is 1 plus 2, that is 3, right? And when x is equal to pi by 4, t is equal to 1 plus 2 times cos square pi by 4, right? And we know that cos pi by 4 is the 1 over square root of 2. So here we have 1 over square root of 2 square, right? So this is 1 plus 2 times 1 over 2, and 2 and 2 get cancelled, so we are left with 1 plus 1, that is 2, right? So when x varies from 0 to pi by 4, t varies from 3 to 2, right? Okay, so once we have changed the limits, and we have here cos x is equal to square root of t minus 1 over 2, what we will do, will differentiate this expression with respect to x, right? So now if we differentiate t is equal to 1 plus 2 cos square x with respect to x, we'll get dt over dx is equal to 0 plus 2 times, here the derivative of cos square x is minus 2 cos x sin x, right? Okay, so now we have minus 4 cos x and sin x, right? Okay, now what we will do, here we have the term sin x. So what we will do, we'll write sin x as square root of 1 minus cos square x, right? So now dt over dx is equal to minus 4 cos x times square root of 1 minus cos square x, and we have changed this expression entirely into cosine x, right? Because see, we have cos x in terms of t, right? So now let us substitute here the value of cosine x, right? So for this cos x, we have square root of t minus 1 over 2, and here we have square root of 1 minus cos square x is equal to t minus 1 over 2, right? So now we can simplify this expression. So we have dt over dx is equal to minus 4, and here we have square root of t minus 1 over square root of 2, and here we can write square root of 2 minus t plus 1 over square root of 2, right? And square root of 2 times square root of 2 is 2, and we can cancel this 4 with this 2, so we are left with minus 2 times square root of t minus 1, and here we have 3 minus t, right? Okay, so now what we will do, we'll combine these two terms, because both these terms t minus 1 and 3 minus t are under the square root sign. So we can now write here t minus 1 and 3 minus t, right? So now let us multiply these two monomials. So we have dt over dx is equal to minus 2, and here we have 3t, then we have minus t square, and then we have minus 3 plus t, right? So we can now write minus 2 times, here we have 3t plus t is 4t minus t square minus 3, right? Okay, so now we can write this quadratic term as we can take negative sign, so we can write minus t square, then we have minus 4t, and we have plus t, right? So now we have here a quadratic term t square minus 4t plus 3. So now what we will do, will convert this expression or quadratic term as a perfect square, right? So what we will do, we'll write minus 2 square root minus t square minus 4t plus 3 can be written as t minus 2 whole square, because we have t square, then we have the 2ab term, that is minus 4t, and then we have plus 4. So in order to eliminate this plus 4, we can write here minus 4, and here we have plus 3, right? So now this can also be written as minus t minus 2 square, and 3 minus 4 is minus 1. So now we can multiply these two terms with this negative sign, so we have 1 minus t minus 2 square, right? So now dt over dx is equal to minus 2 times square root of 1 minus t minus 2 whole square. So viewers, now we can write the value of dx as dt over minus 2 times square root of 1 minus t minus 2 square, right? Okay, so now we have this expression, and now we can rewrite our integral I as see here x is 0. So when x is 0, the value of t was 3, and when x is pi by 4, the value of x was 2, right? So we have 3 to 2, and here we have 1 plus 2 cos square x is t, so we have greatest integer of here t, and for dx we can now write dt over minus 2 times square root of 1 minus t minus 2 square, right? Now let us rearrange this integral. We can write I, and see here we have the negative sign, so we can here reverse the limits. So we have now 2 to 3, we have greatest integer of t dt, and we can take this to outside, that is we have half, and here we have square root of 1 minus t minus 2 whole square, right? So what we have done here, we have used this property, that is a to b, f of t dt is equal to a negative of b to a f of t dt, right? So we can reverse the limits by taking a negative sign, right? Okay, so now we have this integral, and now see here t varies from 2 to 3, right? So when t lies between 2 and 3, then the value of this term, that is greatest integer of t, is equal to 2 by the definition of a greatest integer function, right? So the value of greatest integer of t is 2 when t lies between 2 to 3, where the lower limit is 2 and the upper limit is 3, right? So now we can write half, and here we have 2 to 3, and for this greatest integer of t we can write 2. Here we have dt, and in the denominator we have square root of 1 minus t minus 2 square, right? So this 2 and this 2 get cancelled, so we are left with 2 to 3 dt divided by square root of 1 minus t minus 2 square, right? So now in order to solve this integral, we can again make use of the method of substitution, right? So what we can do, we can write u is equal to t minus 2, right? So t minus 2 can be taken as u, so du is obviously equal to dt, and when t is 2, then u is 2 minus 2, that is 0, and when t is 3, then obviously u is 3 minus 2, that is 1, right? So when t varies from 2 to 3, then u varies from 0 to 1, right? So now this integral I can be written as 0 to 1. For dt we can write du, and in the denominator we have square root of 1 minus u square, right? And from indefinite integrals we know that the integral of 1 over square root of 1 minus x square is equal to sine inverse x, right? So here we have the integral of 1 over square root of 1 minus u square is sine inverse of u, and the limits of integration are from 0 to 1. So now we can substitute the limits and we'll take the difference. So we have sine inverse 1 minus sine inverse 0, and sine inverse 1 is pi by 2, and sine inverse 0 is 0, so this is pi over 2, right? So viewers, the value of this integral involving the integrand as the greatest integer function is equal to pi by 2.